Hello everyone. This is part 2 of homework number 5, and last time we left off with the concept of when the variable is on both sides of the equation, bringing the variable to one side first. And we saw the two situations in this example where if we brought the variable, in this case, to the left, the coefficient of the variable was positive, and if we brought the variable to the right, the coefficient was negative. Now, that's not always the case, but the idea is that if we want to avoid, and I've got a little guideline here, to avoid negative coefficients, because that's where we often make careless mistakes in algebra, is with negative signs, we bring the variable to the side where the coefficient is greater. So we've got two examples here to illustrate. First off, notice that the variable's on both sides, so we want to bring the variable to one side, so then compare their coefficients. And 6 is greater than 4, so therefore I want to bring the variable to the to the left side. Again, because 6 is greater than 4. So I'm going to recopy the equation just because the font size makes it easier for a solution to show the solution. Okay, so if I decided to bring the variable to the left, I'm going to transpose the 4q by adding the opposite or subtracting 4q. We line them up right under like terms, so under the 6q minus 4q, we get 2q, bring down the negative 7, line up the equals, the q's are gone, bring down the 5 and tuck it right in there next to the equal sign. And notice that the coefficient is positive, and now it's our two-step process. So when we have this situation where the variable's on both sides and it's of the form ax plus b equaling, let's say, cx plus d, that is, variable and a constant equals variable and a constant, then it's a three-step process. First step, variable to one side. Second step, constants to the other side. So to get rid of the negative 7, we're going to add 7. Bring down the 2q, the 7s are gone. No need to write a 0. Tuck the 2q right in next to the equals. Do the arithmetic, 5 plus 7 is 12. And then finally our division. So divide by the coefficient, 2. And q is 6. So notice it was a three-step process. Variable on one side was our first step, constants on the other side, second step, and finally the division. So you should get in the habit of being well disciplined and showing your work neatly, because mathematics should be a discipline where there's no guessing, and you don't want to skip steps. You want to show everything nice and fluent, and take one step at a time. Okay, I'm going to recopy this equation as well. And notice first that the variable's on both sides. So then compare the coefficients. And we have 2 compared with 6. 6 is greater than 2. So we're going to bring the variable to the right side. Now, you don't have to do this. You could deal with the negative coefficients. If you were more comfortable bringing the variable to the left side always, then just be careful with the negative signs if you encounter them. But this is just a guideline that sometimes is good practice. So if I want to bring the variables to the right side, I'm going to transpose the 2x by subtracting 2x. Line up the equals, the like terms. The negative 2x right underneath the 6x. The 2x's on the left go away. Bring down the negative 7 and the equals. 6x minus 2x is 4x. And bring down the positive 8. Okay, and then at that point, we've got the variable on the right, so we want to bring the constants to the left. We want to move the positive 8 by adding the opposite or subtracting 8. And combining negative 7 and negative 8, we get negative 15. Line up the equals, bring down the 4x, and the 8's go away. And now we divide by 4, the coefficient of x. So the negative 15 is divided by 4. And here's a case where 4 doesn't go into 15 evenly, and there's no common factor, so that's our answer. So we could have fractions as our answer, and we prefer improper fractions over mixed numbers. So negative 15 over 4 is the way we would prefer to leave that answer. Alright, so now we're going to even extend this concept further. And that is before we transpose. Remember, transpose means to move things from move a term from one side of the equation to the other. We combine like terms on either side of the equation. So before you start the transposition, the worst case you should see is ax plus b equaling cx plus d. That is, variable and a constant equals variable and a constant. If there is more than two things on either side of the equals, remember the equals is a barrier that we only cross by performing our transpositions. If there's more than two things on either side, that means we can combine like terms first. So remember that like terms are x's with x's, m's with m's, n's with n's, or numbers with numbers. We can't combine variables and numbers. And I'm going to use the underlining method to combine the like terms. And I'm not going to recopy, I'll just notice, and we typically will want to combine the variables first. So looking at this, I see a negative 9x and a negative 3x. And remember, the coefficient, the sign that precedes the term, is the sign that belongs to that term. So you want to think of this as combining a negative 9 with a negative 3, which gives negative 12, and we carry along that variable x. And then we combine the constants. Maybe circle them or underline them twice. We have 8 minus 6, which is just simply 2. But remember, you have to put a sign in between to separate the terms. So we have to write plus 2. And that equals on the right is just 5. So we only combine the like terms on either side. Alright, and now we have a situation where we can start the transposition, because we've got the variable on one side, we'll bring the numbers to the other, get rid of the positive 2 by subtracting 2, line up the equals, subtract 2 from the right as well, the 2's go away, bring down the negative 12x, don't lose the negative, so be careful, equals 5 minus 2 is 3, and finally the division, and remember we divide by the coefficient of x, sign included, so divide by negative 12, okay, and we get x equals, alright, I'm going to leave it as 3 over negative 12 for now, but first off, when we have a situation where there is a positive number in the numerator and a negative number in the denominator, it's preferred to write it with the negative number in the numerator and the positive number in the denominator. So instead of 3 over negative 12, negative 3 over 12. Or another option is to put the negative right smack dab out in front of the fraction bar, but typically people won't do that. So this is preferred. But then we want to reduce, and we notice we could divide by 3. So x is equal to -1 over 4. Okay, so now the right-hand side, this is kind of like a worst-case scenario. There's a bunch of stuff on either side of the equation here. And so we want to combine our like terms. So we work on each side separately. The -7m and the 2m combine to give -5m. Combine the constants, a +3 and a -20, combine to give -17. That takes care of that side. On the right side, 5m minus 4m are like terms. That's 1m, or just simply m. And then the -2 and the -3 combine to give -5. And now you have to decide, because the variables on both sides of the equation, decide which side of the equation you want to bring the variable to. And I'm going to choose to use the guideline, and in this case bring the variable to the right hand side, because the coefficient of m is 1, which is greater than a -5 on the number line. So I'm going to transpose the -5m by adding 5m, and 5m underneath the 1m, line up the equals, the addition bar, bring down the -17, equals 1m plus 5m, 6m, bring down the -5. Now I have the variable on the right, so I want the numbers on the left. I'm going to transpose the -5 by adding 5. So add 5 here, line up the equals, addition bar, -17 and 5 combine to give -12, equals 6m, and now finally a division. And we're dividing by 6. So divide the -12 by 6 as well. And we get that m is -2. Okay, so we had talked about the distributive property in lesson number 4. So just to recall what the distributive property is, it's called formally the distributive property of multiplication over addition. If we have a multiplied by b plus c, remember we use the nice little arrows as a guide, and this is multiplication. A is being multiplied by, you could put a little multiplication dot in there if you want between the a and the parentheses, but that's understood. But we're distributing the a through the multiplication over this addition. Now everybody just calls it the distributive property, and we don't typically say the rest of it, but that's what's happening. So the a gets multiplied by b to give us ab, and then the a is distributed over the addition and gets multiplied by c to give us plus ac. So if we ever see parentheses in an equation, here's a general procedure for solving an equation now. If we ever see parentheses, that's the first thing we do is remove them, and that's by the distributive property. And then, if needed, we're going to combine like terms on either side of the equation, and then we can finish. So at this point right here, after you combine like terms on either side, that's where you should obtain the form, worst case, of ax plus b equaling cx plus d. And remember, this is the 3-step process. Variable to one side, constants to the other, then your division. So solving these equations should be systematic. You have to write things down, and you shouldn't have to guess. Now, in this equation here, number 14, I'm going to show the distributive property with our little arrows, And 5 times 3x, you just multiply 5 times 3 to get 15, carry along the x. And then the 5 is distributed to be multiplied by the 9. And 5 times 9 is 45. Make sure you put a little plus in there. Now actually, in this case, I could do two things at once. I removed the parentheses, but then I noticed that these on the right, these are like terms. So I can combine those. And negative 12 plus 42 is a positive 30. And now I have the variable on the left, so I want to bring the constants to the right, or the numbers to the right. I'm going to transpose the 45 by subtracting 45. Forty-fives are gone, bring down the 15x, tuck it in right next to the equals, 30 minus 45, negative 15, and then finally division. So 15x over 15 and negative 15 over 15. And then we just simply get x equals negative 1 in this case. Okay, so then number 15 is probably, if you can handle question 15, then you could pretty much handle all linear equations, because it's a situation where all of the concepts are used. That is, the first step, remove the parentheses by the distributive property. So this 4 is distributed and multiplied by the 3x to give 12x. And then the 4 is distributed to the negative 2 to give negative 8. The closure of the parentheses stops the distribution of the 4, so we just need to recopy the plus 7. And that's equal to, on the right-hand side, we see a set of parentheses, which again must be removed by the distributive property. So the 2 is multiplied by x, and it's understood that there's a 1 in front of that x. So 2 times 1x is 2x. And that 2 is distributed to the negative 5 as well. And 2 times negative 5 is negative 10. And now the closure of the parentheses stops the distribution of the 2. So now we just recopy the plus 4x. Okay, so we've removed the parentheses by the distributive property. But then before we start the transposition once again, we want to combine like terms on either side. Either side. Can't cross the equal sign with combining like terms. Crossing the equals is what we call our transposition. So combine like terms on either side to obtain the worst case scenario of variable and a constant equal variable and a constant. So notice on the left-hand side of the equation, I can only combine these constant terms because there's only one term containing x, so we'll recopy that. Combining a negative 8 and a positive 7, we get negative 1. And that's equal to, on the right-hand side, we can combine the x terms, the 2x and the 4x. And we get 6x, and we'll just have to recopy the negative 10 because there's no other constant term. And now notice that we have that situation. Worst case scenario, 3-step process, right? So coefficients greater on the left, I'll bring the variable to the left by subtracting 6x from both sides. We get 6x, bring down the negative 1, the equals, the 6x's are gone. Bring down the negative 10, tuck it right in there next to the equal sign. Right, now we have the variable on the left, bring the constant to the right, get rid of the negative 1 by adding 1. 1's are gone, bring down the 6x, tuck it right next to the equal sign. Negative 10 combined with a positive 1 is negative 9. And finally the division. And so x is negative 9 over 6, which reduces by a factor of 3 to negative 3 over 2. Okay, so that's homework number 5, and we're going to come back in homework number 6 and extend these concepts even further. But again, if you can handle question number 15, you can kind of see how it just funnels down, right? And when we get to these, it's like just adding one extra step on to the previous concept that we learned. So please be disciplined, write out your solutions neatly, skip steps once you get really proficient, but I would strongly encourage you to write everything out neatly, take one step at a time, because discipline in mathematics is extremely important. So that's the end of homework 5, and we'll see you when you're ready for homework number 6.